Rexnord aerospace products are applied in many different aircraft, from fighter planes to commercial transports. Maintenance of these products require the proper tooling. Buying high-quality bearing products is only the first step toward achieving complete satisfaction on bearing applications. Installation is the crucial step that allows bearing design capabilities to be transformed into in-service performance by the user. I'm Mike Surik, and I am from the Rexnord bearing operation. The purpose of our presentation today is to identify the installation and application benefits of the Schaefer tri-roller swaging tool. In addition, we'd like to demonstrate the ease of application involved in these tools. For many years, Rexnord has used conventional installation tools to secure bearings into housings. Some of the more common methods used today include the anvil stake, the wheel roller, and the Schaefer tri-roller swaging tool. The anvil method may be less expensive because there are simple dies needed. However, the tooling must be inserted into a large hydraulic press. The setup is cumbersome, and large hydraulic presses are tough to find. The important thing here is that the operator does not have complete control over the operation. Oftentimes, something called lip springback occurs, where the material is not properly formed over the housing. If this happens, oftentimes an additional swaging process is required. The wheel roller tool is a common tool used today in industry. It features two rollers that can be adjusted for many size bearings. The drawback of this tool is that the friction created in the groove is caused by the rollers not turning as the same diameter as the tool, thus galling the material. Lack of repeatability and other installation problems led Rexnord to develop its own tools to eliminate these problems. The Schaefer tri-roller swaging tool features three rollers 120 degrees from each other. Such a design enables the roller path to set in the groove and creating a true rolling friction, forming the material over the housing chamfer in an orderly fashion. Because swaging inconsistencies can be a major cause for rejects and expensive bearing replacements, Rexnord designed the tool to be easy to use even by inexperienced personnel. Equipment requirements are minimum. They include a hand-fed drill press. A vertical mill can be used in the same instance. A swaging tool set. For inspection purposes, we will need a 5/1000 feeler gauge and a magnifying glass to inspect the swaged lip. These tools are particularly suited to usage at all levels of maintenance and overhaul, as well as airframe manufacturers and their subcontractors. Let us take a look now and see just how easy it is to utilize this tool. Schaefer tri-roller swaging tools provide simplicity of operation and adaptability to typical shop equipment. A small hand-fed drill press is recommended to install grooved bearings into housings. The roller fixture is inserted into the drill press chuck, and the locating fixture is placed on the drill press bed. Normally, guide bars or other fixtures are used to position the locating fixture for ease and accuracy of repetitive bearing swaging. Prior to bearing installation, clean the housing bore and bearing as necessary to remove all foreign particles and contamination. Apply the proper corrosion protection to the housing bore and bearing bore as required. Insert the bearing into the housing. If an interference fit exists between the bearing and the housing bore, take extreme care in aligning the bearing with the housing prior to pressing it into the housing. The swaging operation involves positioning the housing and bearing on the locating fixture. Guiding the pilot of the roller fixture into the bearing bore without the drill press running will help set up the operation. Start the drill press. It is recommended now that an initial swaging pressure, very lightly, be applied. This will help seat the rollers in position in the bearing groove. It is followed by increased pressure to swage the lip against the housing chamfer. After the process is completed on one side, the bearing and housing are turned over and the opposite side swaged in a similar manner. The initial bearings should be trial swaged at a speed of approximately 100 RPM. Speed may be increased when proper operator proficiency is attained to a spindle speed of a maximum of 225 RPM. Variations in outer race materials, types of equipment, and operator skill may require a change in spindle speed to achieve the most efficient use of these tools. An extension bar on the drill press handle is recommended in order to obtain a feel for the amount of pressure necessary to complete the swaging operation without over-swaging. Inspection of the swage lip is quite simple. The lip should show no evidence of cracks, smearing, or galling, and should be tight against the housing chamfer. A 5 thousandths feeler gauge is recommended to inspect for clearance between the swage lip and housing chamfer, and a magnifying glass is helpful in checking general lip conditions. If the wire gauge fits between the swaged lip and the housing chamfer, the bearings should be re-swaged. If a proof load is required for inspection purposes, apply the load to each side of the swaged bearing's outer race. Under no condition should the proof load be applied to the inner race. Doing so would destroy the bearing. The Schaefer tri-roller swaging tool requires little maintenance. It should be kept clean of all contaminants, and it should be lightly lubricated to provide for corrosion resistance as well as lubrication for the rollers. It can be disassembled by the use of an Allen wrench. The tool may be cleaned by loosening the set screw in the roller fixture and removing the retainer, rollers, bushing, and pin. Clean all foreign contaminants from the parts. Lightly oil the roller fixture and reassemble the parts, making sure that the spherical ends of the rollers are toward the outside of the roller fixture. Retighten the set screw against the milled side of the pin. The rollers, retainer, and bushing should be free to rotate without binding. The successful design and use of these tools within our own plant led many of our customers to standardize on this type of tool wherever possible. Rexnord offers a complete line of standard tools to swage all MS Groove Series Teflon line and metal-to-metal bearings, and Rexnord's new line of roller bearings with a swageable outer race. In addition, Rexnord has designed and will continue to design special installation tools for almost any groove bearing configuration. Some of the more common include a step shank. Such a feature is utilized on larger diameter tools. This step shank enables the user to utilize a simple drill press. On the innovative side, we have what we call a double staking tool. This features a unique roller. With the use of a special staking sleeve, it enables material to be formed in both directions, both over the housing and the bearing OD. Finally, we have what we call a flat roller tool. As you can see, the rollers are flat. This particular tool was utilized to stake a composite OD bearing. It utilized a sleeve without a groove. The rollers form the material in both directions, creating a positive retention. So, in summary, there are several installation and application benefits which we should look at. Simplicity of operation, as we have just seen. Complete operator control during the swaging process. This is important. The tool provides adaptability to existing shop and field equipment, and furthermore, the tool will eliminate expensive scrap during the bearing swaging process. It will further minimize the preload torque effect on the outer ring and provide repeatable swaging at all times. The application benefits include a full thrust capacity of the swage lip. It will minimize outer ring distortion, and the Schaefer tri-roller swaging tool will ensure uniform swaging around the entire bearing circumference. In all of this, the key point to remember is that the operator has complete control during the entire process.